Thanks everyone for coming. It's my real pleasure to be here. As Rune said, I've done pockets of work, and this is my latest pocket about examining early life context with the target that I only recently focused on, which is old age mortality. So that's what I'm going to be talking about today. And welcome from beautiful Madison. This is 12 months a year. It looks just like this. This is as Vern was saying, this is a multidisciplinary set of projects. I'll highlight Hamid quite a bit today, who's an economist by training, but I also worked a lot with Josh and Alberto and a postdoc, recent assistant professor, Joshnan, who's a demographer and sociologist. So it's been a really, this has really enriched how we've thought about the project, what we focused on. So I really am grateful for their collaboration and the different funders. I've got NIA and Guggenheim in particular. Okay, so let's start thinking about death. Here's historical window of this question of period life expectancy starting at birth for the last 100+ years. Just to get, I'm starting with orders of magnitudes of change. So you could think about something like 30 years of gains over a century. Some work with Joshnan has extended work by others that starts to cut that in pieces and say where and when. So the where and when of this table is so that the end result is about 30. And in chunks of 20 years, we're doing the where and when. So in columns is the when, is period life expectancies in the first column between the gains between 1900 and 1920. So that's the when. And then the where, which is to say the ages that are most affected, are in the rows. So how you read this is that the gains associated with very early deaths in this period. So this is the period total of that 20 years. So 8 plus 6 plus 5 will get you to 30 eventually. And what we observe, which others have observed, some of these numbers have appeared in many papers. We're just filling out the rest of the details of more recent data. But we observe overall, these numbers are getting smaller over time by quite a bit. We observe, think of that as slowing down. And if we were apportioning the gains, where do they come from in the life cycle? 2/3 or more are early. Big chunks are quite early. So massive reductions in infant mortality and child mortality are a major explanation here of what's happened in period life expectancy gains over the last century. And then tilting this question on its end is what's left on the table type of calculation. So these are period life expectancy gains if we shut off age-0 mortality entirely at different points in time. So the gains, and these were the gains, US is in red, other countries or other rich countries are averaged in black, and then the grays are each individual country. Really what I want to point out here is that by now, the additional gains left on the table from completely solving early deaths aren't very big. While the gains in advances in later life are kind of what's left. Those are targets that we have not completely exhausted in extending period life expectancy in reducing mortality rates. So what do we know? So as I said, I'm going to be examining old age mortality as these target outcomes. So this is this question of like, where might there be interventions on the table that could produce gains where we actually have gains to do, which is to say there's many ages where the leftover gains are quite small. So summing up that, because I'm going to be examining old age mortality, just to have in your mind, the total life expectancy gains after age 65 over a century plus are on the order of 4.5 years. So again, this from that first table, the whole gains are 30. Most of those gains came from early life. So the amount of those 30 years that were from 65 plus is something like 4.5 years, plus or minus. There's a lot left on the table. And then some claims. My claim is that we don't have very good evidence of
post-65 mortality gains. A side claim is the last point, which is, are the data sets that we have in the US, I'm going to be talking about the US almost entirely today, up to this task of answering these questions in a useful way of how could we get 65-year-olds to become 66-year-olds, 70-year-olds to become 71-year-olds, and so on. And I carve up our data space in, now I have the benefit of knowing what's to come later, so which is to say, when I say that HRS and NHATS and WLS are probably too small, it's because of what I'm going to show you later, of when I have bigger data, like what size effects am I finding, and then looking back to say, are these other regular data sets, hundreds of millions of dollars invested in these data sets, could they answer these questions? And I think the answer is no. So that's the too small part. Too few X's is a little bit more, maybe more self-explanatory. Our vital statistics collect a small amount of information, and we can get some powered effects, but we have a limited amount of X's that we can examine. And then a claim more, because some of you might have great access to Medicare claims data. Medicare claims is one of several data sets that might be able to help here a lot, but is very costly in time and money. So this is a little bit of a call to maybe convince some of you to raise your voices, because this is a fixable problem. These data are just sitting there, and CMS rents them out at really high prices to people like us, and that need not be the case. So put that aside afterwards. But I think of those as an explanation of why we don't know very much about old age mortality in the US, is that it's not that we couldn't figure it out if we had the data. I think it's that the data have these particular limitations. So what I'm going to be describing here is a new data source that is quite imperfect, but that moves us away from these issues in, I think, an interesting way, and therefore will give some more information that we don't have before this new data set was released. So early life affecting late life. Many of you already know the many precedents of this examination. I'll just quickly highlight Barker's contribution and conjecture about focusing on nutrition as a key mechanism of how fetal development shifts resources towards some organs versus others, and where the key insight is you may not see these effects right after birth. You might have to wait a long time to actually see the product of very early life insults. This conjecture has been tested many times, and I'll even widen from Barker hypothesis to just fetal origins, maybe more generally, of conditions during, especially in utero development, potentially setting the parameters that our body uses for much of the rest of our life about how we deal with stressors and insults and so on, about how we deploy resources. And so the lower left is the well-known Doug Allman paper about the 1918 influenza pandemic. If you were in utero and you fast forward 60 years, you have this bump up in disability measures from census data. On the lower right is colleague Lauren Smits, who examined health and retirement survey respondents and their epigenetic aging profiles around age 80, and then went back in time to say, how bad were your material conditions based on where you lived and when you were born back in the 30s. And those who experienced bad conditions in utero had higher rates of aging as measured by epigenetics around age 80. But she found much less evidence for similar disadvantages, but experienced at other ages. So this is some evidence of in utero exposures to this type of environmental condition having unusually big. So this is like a sensitive period type set of findings. Love this quote from the popular book from Peter Attia, which is a dismissal of, not dismissal. It's an answer. It's another answer to the question of why we don't know anything. Like he gives his answers in the book, you know, exercise more and so on. But as like a side note of why his evidence is the best evidence, and we could really not find, there's no other way of getting it, is this quote of, if we really wanted to, you know the answer, we'd have to do RCTs of hundreds of, he takes 100,000 babies, randomize them to 4 to 5 different interventions and follow them throughout their life. That would hopefully yield a rock solid evidence-based prescription for maximizing lifespan. The obstacles to doing this are insurmountable, not least because it would require a century to complete. So there's some important notes there about the timing that we're talking about. That old age mortality is by definition 60, 70, 80 years apart from the conditions that we're interested in. So I'm not proposing to do this, but it's reminding us of the timing and what other disciplines think of as like the way to do it. So I'm going to describe a way that we all would do it, maybe, is to, instead of starting the clock now and taking 4 or 5 conditions, I don't know where these conditions come from, how you would choose those 4 to 5 RCT conditions, but nonetheless, you could do it that way. I'm going to do the opposite. I'm going to start at the end of life and then work backwards, right? So I'm going to take recent descendants, the last few decades anyway, but I still have this complication of the 60, 70, 80 years that you have to go back. And as you go backwards in US time, you run out of data. Right. So the data collected in the 20s and the 30s and 1910s looks really different than data collected now. And so that's going to be a real hard constraint on the types of exercises one can do. I've already picked on the HRS, but you could use the HRS exactly in this way. Have current people some of them die in any wave, and you know by self-reports and census links like where they were born. But you start with sample sizes that are orders of magnitude different than what I think we actually need. So more on that. But on the data side, you run out of room in many ways as you move backwards in time. So just a couple notes about where this mortality system was complete in 1933, so not before that. We have aggregate statistics in the 1900s. If you wanted to do this at the individual, big data, individual mortality records, you can't go back so far. So there's some real constraints that are relevant for the US case. So here's the imperfect savior that I'll describe. So I really love talking about this data first and foremost because it's public use. You can download it today. So Josh excuse me, received an NIH grant several years ago to take the 1940 complete count census, which at the time was recently released, and based on regular name matches and other X's matching, match it to pneumatin death records and death master file. And so he has 3 different matches that he's done, or 3 different data sets that he's compiled based on these type of matches. There's DMF based, so that this is a little bit more still advertising because you can download these today and start to work. But there's some choices to make. Death master files, recognize the first row as men only. I'll be showing you some evidence of this men only data set. So this, many of you know about matching and women's last names changing creates issues of match rates. Some of these are, I think, being solved in other groups, but at the time of these matches, made a decision to create one data set that was high amount of matches because the men only. It has this checkbox because it was linked to the 1940 census, and importantly, here are the years where you have that the student information, and on the order of 8 million records. Separate match to pneumatin, where you have not just men. The main trade-off is the years. Okay, so you have this shrunken window of when you see people die. And then this is a version that's really just pneumatin. It's a clean pneumatin data, but not linked to any census. And you have 50 million. So there's so it turns out pneumatin he's added a field for county of birth or place of birth. So this file does not have any census information
but for purposes like in utero exposure, county of birth is really great. So this is something one could use.
Just a clarification question. So you only have the names for the adults in the household? Because I noticed that you said birth cohorts in 1910, there's you don't have people 1940 who are like 1 year old, 2 years old in the household.
Great question. So this sentence is not, this is an add-on about what I'm doing with it. So this table is just what's in the data. What's in the data are people linked between 40 and death. Now, just to add to that, so you have someone in 1940, you see that person in the death records. That person in 1940, you can link backwards through regular matching to other censuses. If you want to pick up information just to play this out. This is getting our attention to, at the ages I'm talking about, with the death windows I'm talking about, the core birth cohorts that fit best in this data structure are something like this. When you put constraints on, they have to live this long to be in the data, and I'm only looking at older ages, older deaths, then something like this is the Goldilocks part of the data. But this is something I'm adding as a constraint. It's not a constraint in the data itself. Other questions about the data? Free, public.
Very useful, still underexplored. This is restating it. So the exercise is bring in this new data set, at the time new, now several years old, focus on some particular birth cohorts, fast forward to pick up mortality, and then what you're going to see is a lot of difference in difference exercises. You know, things happened between 1910 and 1920 at times and places. So therefore, some people were exposed to them and others weren't in utero or at age 1. And with lots of data, you can measure modest effect sizes in terms of old age mortality. And as you know, 1950 is out still, maybe in beta mode, and there's some more recent. So this is an own goal of ours in the U.S. Obviously, we have data past 2005, but there's been policy decisions about what can and can't be released after 2005 that really destroy a lot of like a public version of this. So this, like I said, the data are there. We kind of decided that we're not going to use it because of privacy issues and other things. So there's some recent mortality data, but this is a really difficult constraint. It's something like, this is not exactly right, but it's something like the federal government went from states, you must give us the data, to you don't have to give us the data. It's something like that. And the coverage in these files have really fallen past 2005. It's a real limitation in what we can know from data. So, but with this data set, I mean, and some what's the right word? Hubris of trying to be a little bit of a historian that you're not, which is both of us. But we had to put on this hat of, well, what was happening in the 1910 to 1930 sets of cohorts that might actually have a persistent effect. And so these are some of the things that we've examined. So just like one example is just like, oh, remember when, you know, in the 1920s, there were places, counties, then states in the federal government that put prohibitions on alcohol, right? And in particular, and from our perspective, exposure during in utero to alcohol. So, of course, we haven't had that in many, many decades. But if you go back in time, you pick up, you know, instances where cities brought in their first water filtration systems and so on and so forth. Today, I'm going to like zero in on one snippet, which is area exposure to lynching, which is, let's say, lynchings that racially motivated lynchings that happen in places, as for instance, you know, diff of what we can detect much later. But each of these are, you know, its own project, and many more of just like, you know, lots of things happen in these years that have some plausible, have some possible effect on old age mortality that we're investigating.
So let me do a little bit of a deeper dive as a for instance, and then I'm going to zoom back out to showing you a lot of results that we found. So the for instance is this exposure to racial violence. So this is an in utero paper. Let me give you very briefly some papers that suggest there might be this effect that we might find. So we're going to be examining lynchings that happen when the target person was in utero. So there's certainly evidence of stress exposure, if we think of a stress mechanism. And then there's more recent evidence of, violence surrounding the pregnancy affecting preterm birth and low birth weight. And then something that might be similar to lynchings affecting stress, maybe through mental health. And this could be a much larger slide. This is the snippet version of this paper. So we take in this case, the best master file, so many millions of people. And the obvious thing is that we know based on their birth date and their birth county, when and where they were gestating. And then separately, we move over to a data set that's been compiled that lists, these rows are in the state in Louisiana, 1902, March 19th, the victim's name, the victim's race. And so there's a listing of over 1,000 lynchings that happened in the US over this time period. Again, importantly, time and place, right? So you have this dot on the map of when and where this particular lynching happened. And we're just going to, and this is the flattened version, we have 30 plus years of lynchings here. And we're showing at the county level which counties had a lynching during that period. Of course, all these are time stamped also. So to go back, our research design is that we're going to end up throwing away almost all our data in order to focus very narrowly on instances where we're going to take individuals born in a narrow window around this time and place stamped lynching, and then compare those two people over time. Might be worried about places that have one lynching might have many. And so this is so within 12 months, a county that has a lynching, only 3% of them have one within that next year, just to give you a sense of timing. Over time, lynchings do in some sense cluster, but because we're dealing with these like 18-month windows, we don't have a big problem with those windows. So like our data look like this. So this is the state of Alabama sliced in the counties. The counties are going to be our main unit in some sense. And each of these blue bars is, here's a lynching that happened in that county. So we're basically going to be taking, and this is 40 years of data, so, right? That blue horizontal is 40 years. So even the lines that look kind of simple, like close to one another, they're actually like several years apart, not mostly a decade apart. There's only a couple instances like here where they're close enough that we'll throw them out for some of our analysis because there's you're getting multiple doses of lynching. But we have this, of course, for all the states, but this might give you some intuition of what we're doing. We're drawing 18-month windows around each of these, grabbing all the individuals who are either exposed or just barely missed exposure, right? Questions about?
So sorry, just for full clarity, you're saying that the lynching the birth sets the clock? No. How do you do it exactly? So that, explain the window.
Thank you for that question. So every birth, we're going to have this 9-month window around it. Right, so you have the birth and you're going to go back 9 months. And then for every person that has that 9-month window, we're going to say, does that window include this spike when you're treated? Or are you within 18 months of this, but your window does not include that spike, so you're untreated?
So you do standard birth, counting back, assuming in 40 weeks gestation, and take the 40 weeks
Yes.
counting back.
Yes. Yes, at the moment. Yep.
And to clarify, basically the same question, but so therefore your models or you're assuming that the gestation was physically in the same place as the birth location.
So that again, we're assuming that the birth location and the
No movement during pregnancy.
Yeah. So you're assuming no movement during pregnancy.
yeah. So
Yeah. It's
no, I'm not trying to push back.
and not even assessing like how good of, I want to make sure I'm answering the question correctly. We're taking the county of birth as described in the social security records and saying that's where you were born. And you're right that during pregnancy, we could have some measurement error if they were moving during those 9 months, then they could, that's true, definitely true. Anything? So this is actually a good time to describe in more detail. We're talking about 1929. So just to underline what we do not have measures for, self-reports of stress. We would love self-reports by mothers by pregnant people in 1921 of stress or nutrition. So that's all to say, of course, we don't have that information, and that the effects I'm going to show you are intent to treat effects. I was born in this county and this time. We don't know if that family had any knowledge of this lynching, right? And this is, I want to show, this is partly again to pair it with health and retirement or other data gathering. So we start with something like 6 million people. We're going to throw away a bunch of them because they're not in the South. Like we're going to focus mostly on the South. So that's based on our design. Some of them aren't born in the right window. They're too old or too young. And then so this number is 1.6 million. And then we're going to get rid of a whole lot of people because of that window that we're imposing, right? So we're essentially zeroing in on 1% of the full population or so. So if you can imagine trying to do that with other data structures that start at 30,000 people, you can see why you just couldn't implement most of the types of work we're doing in other size data structures. This is not the only choice one could make, and I would love if other people made other choices. This is, again, underlying public use. You can download it all right now and make other choices. So we're going to rely on 60,000 people who were all born in these windows across about 1,000, I think it's 800 to 1,000 lynchings in the data. And otherwise it's diff and diff. It's just comparing these, treated versus control in the same, a lynching event will be a time and place stamped, event. We'd be worried, of course, this is not an RCT. We're worried that people exposed might be different. This is a 10-minute presentation of a 60-page paper. So there's a lot of tables one you can go examine, but we do the things about diff and diff where we ask, does lynching quote affect maternal education? It should not, all those kind of things. We use other diff and diff methods. There's some big states that might be strange in this context. We either drop them or not. The other thing that I haven't mentioned so far is maybe it's a reminder, but maybe it's new information. Linking people based on names has had a lot of advances over the last few years, but still the rates here are in the 10%, 15%. You're based on only names. So, you're taking a census record and the enumerator writing a name in 1910 or 1920, and you're matching that to a name in the death records. And there's a window around which you have some tolerance of the age is not matching. But otherwise, there's a lot of ways for that to go wrong. There's a lot of common names that are hard to match and so on. So just recognize that that's in these data. It's in any of these name-based match data. What we try to do affirmatively here is ask, is treatment related to the likelihood of matching? That's what we're worried about, right? Are counties that will have a lynching, do people in those places have different match rates? Now because we're doing diff and diff, they need to have different match rates in this window, in this tight window. So we feel, and we can demonstrate that we seem pretty good on that particular measure, that people in these counties born in slightly different time periods have the same likelihood of getting into the match, of being matched. Yes.
To somebody who hasn't died yet, how are you distinguishing that from a non-match, or are you restricting the age groups to kind of guarantee that everyone should have died by then?
Great, wonderful question. So we face, so let me just add a sentence or two. So you can have a match failure because, and this is what really bites this in one way. Of course, your name could be common and it's hard to figure out if you're the right John Smith. Or, as Maureen was saying, this window is important. If you die a year before the window, you died too early to be matched. Or you could die the year after the window and be too late. And we know neither of those. We don't. So it'd be one thing if we knew that we're all too late or all too early. We can do that by, as this is getting to your point, we can do that by narrowing the ages that are eligible, and we do that. But every change in the data we do, we're changing what cohorts we're talking about and what ages, so that it's not for free. But you're right that every time you, so let me restate what this is. This is just for any reason not being matched. It's unrelated to treatment. We don't know. We can't separately say you weren't matched because you died too old. Separately, you died too young. Separately, you died because you had a common name. We just know match yes or no. So overall, we can say, do people who we call treated based on this time and place, are they more or less likely to be matched? We can test that and show that they're not, but we can't do this too early, too late thing. So it's another, I'll underline like great public free data, imperfect data. So here's our orders of magnitude. These are in months. So individuals in that window of treatment versus the window of control. This is where our headline is about 3.5 months of old age mortality. So after age 65, again, let me remind you of one way to put that in context. You can come up with a different one. Over 100 years, post 65 mortality gains were about 4.5 years for the US population. This is 3.5 months for this one treatment.
Give me the estimates associated with the main effects to understand the consequences of the phenomenon, like what happened with white babies then.
Yeah, thank you. Yeah. So 0 is the answer to white babies. I mean, you want, well, they don't have to be 0. They turn out to be 0. Yes, good. I think I dropped that table. 0 for them. I'll show you, like, there's a graph that shows that, but that's where the answer is. And we can do a little bit extra of so right now lynching means in this table, a lynching is the lynched person was black. That's not all the lynchings in the data. There are small number of white lynchings. So we can do the exercise. We're have less power on all these exercises. So there's no effect of, so this is Clarence's question, and I'll show you a graph of that in a minute. But we also find no effects of white lynchings, so we could be underpowered there. Or it could just be a different thing than black, right? And there's another data set of just broad public executions that, and we asked if it was just this experience of a public death. And that we find no effects of those. There's a question that we can provide some evidence for, not definitive evidence of, is the stress so big from lynchings that we might find infant mortality or birth change or surviving birth changes. So we don't find that. So we have to shift data sets to do this analysis, because this is now an infant mortality rate, which is a county level phenomenon. So now we're moving over. We're no longer at all in the debt master file, no longer all in the census file. There's a different file of county to county. There's measured potential issues here. But if you look at the, so this is just asking for counties that have a lynching, is there higher infant mortality compared to counties that don't? And there's positive, but the implied effect sizes are really tiny. This is a 1% change in the infant mortality rate. So we say we don't find much evidence of this affecting survival of gestation. Here's the closest thing I can show on the table or the figure for Valencia. So this is the
Now. It's last table was in utero effects. We're gonna compare in utero effects to age 0 to 1, 1, 2, and each individual coefficient doesn't have a lot of power to compare across them. If you want to split, let's say these in utero effects look somewhat different than the rest of them. You would say I can't rule out small effects, smallest effects, but it looks like in utero might be special here. And here's the zeros for whites that you were asking for. This is both the in utero 0 and for the rest of the ages. Yes.
I have a question, so are you, like the outcome variable, are you just observing whether or not a individual appears?
It's their age of death. So it's the unit, the effect sizes for the units are in months of old age, longevity. This is to say, we can try to carve the data in a lot of ways, and we think with even starting with 60,000 people, we're not powered to find a lot of heterogeneity. So here's some examples of what we're not powered to do. We of course would like to know about trimester effects and so on. It's not for one of, we'd like to know that. We don't think we have the power to detect.
You don't have gestational genetic data for this, so you're always counting 50, 40
We are.
years back, so it's.
No, there's, yeah, we didn't even go to, making reasonable changes to this 40 weeks, because I think we're just not gonna find anything regardless. So we just not have pursued different corrections one might try to consider for preterm and other births that are not in the data. But I think the answer is going to be, we're not gonna be able to tell the difference between those three with our sample size.
Oh, and all your confidence intervals that you have showed us are at the 90%. Are 90%, correct?
It does say that here,
Those are two.
these are all
numbers.
95.
95, okay, so
Yeah, next year shows both. This one you mean? That's, oh yeah, I can't speak to why this particular one is so different. Yeah, so this is both. You see a little tiny change in color there, but to answer your good question, your correct, good question, the rest of them have been 95. Like the one that I showed you. This is stretching the data a little bit more now. Okay, and for intermediate steps leading, before death, you can examine some outcomes in the census. And I would say I label this tense because these effect sizes aren't very big from what I would have maybe guessed. So individuals, have this in exposure, have small reduction in schooling, later socioeconomic status is relatively small-ish. So we'd say that these are, these are candidate small parts of the story of a much, of a post-65 reduction of almost 4 months of life. But we kind of run out of room in, so out as we were doing this, the lynchings occurred, 1940 census is captured, and we don't know anything until 1975. So there's a lot of candidate mechanisms that when you add the 1950 census, maybe you can start doing a little bit more, but we are just limited by what would be in the 1950 census that would be really relevant. The decennial censuses do not ask health, especially in these days. So we can further examine socioeconomic status as measured by the census or occupational for another 10 years. But we're kind of left with a black box between the two. So snippet, and then I've got one more slide before I do, I think, more Q&A. This is a relatively large, when we first started getting effects of like 3 or 4 months, I thought, not very good. But as we've thought about it more and tried to think about other ways of benchmarking it, I think we're coming to a conclusion that these are certainly non-trivial, maybe more than modest effect sizes, especially. So there's a couple notes to come back to. These are intent to treat effects. So there's something you're probably blowing up it in some way, depending on what you think.
the proportion of people who like had no idea that there was a lynching that happened and so on. So they're probably bigger than this for treatment on the treated. And if you, again, benchmark it against, all the gains of life over many, many years of being, 4.5 to 5 years, then these are gonna start, I think, adding up. And, they're of this piece of what's happening now, violence is happening now for, during in utero, during pregnancies right now, have a very, very long shadow that we're never calculating as costs to violence and so on right now. So this would be another piece of, total kind of cost benefit analysis of reducing violence would include deaths that happen much, much later. So that's the snippet. Let me give you one more, because this is going to take a little bit of time to talk about in my last few minutes. So I just told you about this row. So let me then say, what are we finding more generally? So each of these rows is a different project, and so we have some benchmarking projects up here, these are not in utero exposures or early life exposures. These are going to college, or there's a social security notch that affect late life income for these cohorts. So, other non-in utero effects, but the effects that have literatures around them. And in each of these cases, I've got a design or a method of what we're doing. So like later life income, we have a regressionist continuity around the 1917 cohort that experienced this social security notch. And then if you read over like affected cohorts, in this case, we have a treatment on the treated of 1.5 months longevity, more life. So down here, black is positive effects, red is negative effects on longevity. So these are like benchmarking of, late life income, another example, if a college opened when you were 17 in your county, this is the effect on your longevity. If it induced you to go to college, so that's considered to treat, you have a 1-year increase in post 65 longevity. So these are some, like, how big are these things? And then these rows are mostly in utero and early childhood exposures. And this is what we have been seeing, 2 months, 1 month, 3 months, and so on. I'll give you, this one's particularly fun. This row called pesticide cicada. Because, obviously we have no measures of pesticide exposure for 1920 for pregnancies. But cicadas, there's other papers that show that cicada events, we know exactly when they're happening and where. And back in these times, they were met with tremendous pesticide, for, I might be missing this now, it's apple, so it's tree crops and not row crops. Cicadas affect apples and not corn. So we can go back in time and ask, well, were you born in a county, in an apple producing county, in a cicada event on a farm? Because the census tells us what your father's occupation was, right? And for those people, so being born in the wrong time, the wrong place, it's not, I don't think I have it here. So if you were just in the wrong county, you were in an apple producing county in a cicada year, you live about 2 months less. If you also have a farmer father, it's 10 months. So I like that example because I'm underlining again, I'm calling it pesticide, but the treatment here is cicadas. So it's going back in time 100 years and saying, what about our knowledge of what was going on back then? Might we then be able to link with something of more current concern? And then there's also other changes in the environment through policy and so on that affected some people in some places. And each of these cases, it's like the lynching one I described. There's time variation, place variation, and were you affected? Were you in the right county that had malaria eradication? That's ongoing. What about hookworm? You were in hookworm county that had hookworm eradication. Right time, right place. You live about a month and a third longer. And then in many cases, but not all, we can cut the data because some of these are very big samples and show heterogeneity. Like Black individuals have not 1 and a third, but more like 2.5, say, months. So this is a a bird's eye view of the accumulation of early life effects, all on old age, that individually have, I think, non-trivial effects. And some of the things that we're going to be doing next, or continuing to do, is other exposures, other things happen. We haven't really done a lot with the two world wars yet. We haven't done much with the census, but what we're really interested in is finding interactions among exposures. We have people who are exposed here and then there and then there, and ask if those things have multiplicative effects. So I'll conclude by, again, 4.5 years being one metric you could have in mind. We find evidence of many effects in the 1 to 6 month size of early environments. We think that puts maybe to the unconverted, early life is a central policy domain to shift what's of high importance, which is getting people to live longer. We've mostly but not entirely solved the early life mortality in rich countries. It's the later life mortality that has a lot of, I think, potential gains on the table. So with that, I'll thank you and ask for any more questions.